thing to do. So to that end, there is this assessment, and I use the word assessment very, very lightly, course, where, let me go ahead and jump over to it, to the announcement that I specifically sent out on this. This is extra credit. So that's probably the most important detail to this whole thing. This is extra credit. This is not, if you don't do it, it's not going to hurt your grade. But I heavily encourage you all to do it, because it's 1% extra credit for the pre-assessment. And at the very end of the class, it'll be 1% extra credit for doing the post-assessment. This is a very useful tool for the department to be able to determine basically, are one, across the board are students learning? And then two, are we consistent? Are we consistently teaching what we need to teach? So even as an adjunct instructor, I'm still supposed to be teaching you all the same things as everyone else. And so this is a good metric to make sure that's happening. So this is available, it'll be available through January 21st, not that many more days, so it's only open for a week. So you've got a few more days for it. The pre-assessment, we do not expect you to know how to do all those problems right now. So the way it works is we ask you a bunch of questions in the beginning, because we have to get a sense of what you currently know at the beginning of the class, because every single student in here comes with different amounts of knowledge. Some of you all have taken physics in high school, some of you haven't. Some of you took AP in high school, some of you took honors in high school, some of you didn't take it. So it all varies. So we take the pre-assessment, and then we compare your scores to the post-assessment. If we just did a post-assessment, there's no way to kind of control for your existing knowledge. That's just fun research kind of information for you all. So please, please, please do this thing. Again, if nothing else, it's worth 1% extra credit, but it'll also give you a sense of what we're going to cover in the entire class. And at the end, it can be kind of a nice little thing to test. Almost like a practiced final exam. So it's useful for you all in a whole bunch of different ways. All right, next announcement. There is 2 resources that you all can go to in addition to my office hours where you can get one-on-one assistance with this class. This is super, super useful to you all. I'll straight up tell you, lecturing is the worst way, in my opinion. I guess the only way to be worse is if it was purely online. I don't know, maybe not. Lecturing, in my opinion, is one of the worst ways to teach, but it is the only way to teach basically more than 100 students. When you have scale, that's just how it goes. Honestly, I do a better job of teaching my high school students than I do of you all because I have 20 of them in a room. I get to actually engage with them, work with them, ask them questions, get to know them, figure out the minutiae in terms of, because the challenges each one of you encounter in this class is going to vary because you're all unique and beautiful human beings, and that's just the nature of human beings. We're complicated. We're unique. So to that end, there's 2 resources. I ideally would have put this in one announcement, but I sent out the first one and then got an email with the details of the second one like 30 minutes later. So one of them is the physics help room. This is staffed by individuals. Both of these are kind of very similar. They're both staffed. So I have physics help room, and then I'll talk about SARC. Both staffed by undergraduates who are very successful in these courses. They took these courses, they were successful in them, and then they've usually part of these programs that take some classes. So the physics help room, I posted the schedule here. Here's what it looks like. These students, it tells you what class you are in Physics 1, so it works, every single one works for you. Not all of these students have taken Physics 2 yet, so that's why some of them don't have the Physics 2. Anyway, they're available at all different times. So if you can't make it to my office hours, this is another option to go to. If this doesn't work for you for some reason, there's also SARC. So SARC, I posted their hours. There's 2 different tutors for SARC. Their hours are located here. So Tuesday and Thursday from 9:30 to 11:30. And then Tuesday, Wednesday, 3 to 5. And then oh, look at that one. It's online, but it's right after this class. So anyway, lots and lots and lots of options, y'all. Yeah.
For the PDF for the physics.
Is it not working?
It's not working.
All right. I'm going to make a note of that. I'll post that. I would have sent you to the online, so the Physics Help Room has a website, but they have not updated their PDF yet. So let me fix that. Fix Help Room PDF, because I can guarantee you by the end of class today I'll forget. Yeah, thank you for the heads up there. If I don't do it by next class, shoot me an email and I'll definitely get that fixed. My apologies there. So, there you go. Lots and lots of resources. Y'all take advantage of them. Okay. Reminder to you all, your first quiz is due this Saturday. That's on units and vectors. If you have not started the problem set for units and vectors, you are kind of behind in some ways. My recommendation to you all in general is after we cover the content, you should ideally start doing the problems for that content sometime during that week. Sometime during it. You can generally start, so usually the first few problems you can get through after day 1, the next few after that, and the next few after that. They're in the order we learned. To that end, I highly, highly recommend you get 2 quiz attempts, that you do 1 of the attempts by Thursday or Friday or even today, because the quiz attempts, every single quiz question has 4 different versions. They are very slightly different from each other. So if you look at the quiz, you take it again, you look at the next one, you say, this looks identical. Yeah, 90 to 95% of it is identical, but you only have a 1 in 4 chance of it being the exact same. So, to that end, I straight up tell you that because when you take the quiz version, you should be as prepared as possible when you first start it. So ideally, you've gone through all the problem sets. But you definitely want to take the first quiz one way or the other sooner than later so that you know exactly what to also prepare for that. Because once you take it once, I want you to learn from your mistakes. You can look at the quiz, you can see which questions you missed. Make sure you know why you missed them, then take the second attempt. If you wait till Saturday to do both attempts, 1, you haven't given yourself time to learn from them. 2, if you send me an email, I'm not going to respond to it because it's a weekend, and remember I told you all, throughout the week, yeah, I'm on it emails-wise. But on the weekend, I'm spending time with my family, work-life boundaries, all that jazz. I will not respond to your email till Monday. So, maybe you got a 1 in 10 shot of me checking my email, but it's very unlikely. So keep that in mind, y'all. Do it sooner than later. Do your best. If you've done the problem set problems, you should have no concern with these. Quiz questions, honestly, you all should get all the points for. As long as you put an effort, you should be successful on them. The only reason if it's not going well, make certain you're going to tutoring, make certain you're going to help room hours, make certain you're doing the problem set problems, make certain you're using the resources that are available. Make sure you're emailing me, all the things. If you're doing all those and it's still not working out, then yeah, talk to me. We'll figure out something. We'll figure out what's maybe missing or stuff like that. Okay, so that's just general logistics stuff. Discussions, another fun thing. So what's awesome is this class has grown because they've added a couple discussion sections. The complications that have emerged from that is ideally I merged all the classes into one big web courses. I could only do that before classes started, which means when they added these 2 discussion sections, I'm not easily able to merge those. So to that end, they're going to be separate. It's fine. I just synced. I didn't even know they were there. No one told me. I just found them. So thankfully, I was able to figure that out, but I've added all the activities. This week, and this week only, I've given you unlimited attempts on the recitation activity because there was no recitation on Monday. I have a recitation section on Monday. I did not want to penalize them for not having the instructor there, the TA to help them out. I also, to make it fair for everyone, attendance for the recitation this week is not counting. If it didn't count for the Monday section, I'm going to hold that true for all the others. Equity, all that jazz. Moving forward, you will only have 2 attempts on every recitation activity. If you go to the recitations, they will go through the problems with you, guaranteeing that you're going to be successful on them. If you don't, it's on you. If you have questions about the recitation problems, send them to your TA. That's what they're there for. Anything else, send it to me. But recitation questions, please contact your TA, Division of Labor, and all that good stuff. And again, ideally you're at the session and they can answer the questions there. So, all right, I think I covered mostly all the things. If I missed anything, hopefully I'll remember by the end. But that should cover the gist of it. Let's get to 1D kinematics. So, last class, we finished up with units. We finished up with vectors. We said, ooh, vectors, so much fun. Who doesn't love some good trigonometry? We reminded ourselves that everything has to be in base units. We're going to see that throughout this class. You're going to see that throughout your engineering career / science career. Very, very important that you have things in base units because the equations only work in base units. So, and almost every quiz I give you, you're going to have to convert units. It's just a thing to get used to. We started to get into kinematics. Ideally, I would have started Vanilla Code this Monday. Didn't have class Monday. I'll tell you all, when I planned this course, I had forgotten that Monday was going to be absent. So to that end, 1D kinematics will probably roll into this next Monday a bit, and then just each week we'll kind of make up that time that we need to. But we'll see what happens. So we started 1D kinematics. We said, what is kinematics? It's a study of motion. And then all I got to introduce was position, where something is located. It's a vector because you need to know how far away it is and in what direction. That's a definition of a vector. And then we also said you have to have a reference point. If I said I'm 5 meters away from what? You have to define a location to reference, otherwise it's arbitrary. And then I believe I put this one up here, so then the next kind of step is displacement. Position is where you're at. Displacement is how far you've moved. The really important thing about displacement, so again, it's a vector. This delta here, this triangle means, so you can see here, for one-dimensional, we only care about the x, but next week we're going to get into the x and y. So a change means final minus initial. This delta symbol, we're going to see a lot in this class. We're going to see it a lot in general. So the change in position is displacement. And instead of writing the word change every time, we use this triangle, the capital Greek letter delta. Sororities is tri-delta. That's delta. There you go. See, you all get to learn some Greek in here. A lot of Greek, actually, because there's only so many letters in the alphabet, so we need Greek to make up the difference. So xf minus xo, that's another thing that may be different that you all haven't seen before. And if you took high school physics, you may have seen it as xi. So xf, final position. X for in the x direction where you're located. F for final. XO, or not, x naught, either one. That's your initial position. XI, x naught, they mean the same exact thing. Because you all are largely engineering and science, specifically in that kind of realm of science majors, the notation I teach you all is really important because it's going to be fairly consistent across your classes. Not 100%, but I try to be very intentional with the notation I use. If I was teaching you all, and this was maybe a algebra-based course, I would put xi because honestly that's easier to understand. I for initial. But x naught, that's the traditional notation for your starting position. All right, and it's measured in meters. Fairly straightforward. Okay. There is distance and there is displacement, and they are not the same thing. Distance is how far you traveled. It's a scalar. It doesn't care what you did. It just cares. Think of it like your steps. When you measure your steps, or if your phone somehow or your watch somehow tracks how far you walked during the day. It doesn't matter how you walked. You can be walking in circles, and it will add up that number. Displacement, the beginning and the end matters. So if I start at my desk and I mosey around this room, and who cares what path I take, if I end up back where I started, the displacement is 0. It's kind of a funky thing. You're like, why is that useful? Trust me, it's going to be. We're going to see it at play. Direction matters. If I end where I started, the displacement is 0. We're going to almost exclusively use displacement, but it is important for us to make certain, why aren't I just using distance? That's the word we're far more probably used to. Displacement is a special word that means a special thing, and so we got to be careful with our terminology. As you get into science, the words you use, in general in life, the words you use matter. That also holds to science. So, clicker question. If a car goes once around a roundabout, so a roundabout's just a big old circle, with a radius of 20 meters, what is the distance traveled? And I'm going to get out my calculator in preparation for the math I inevitably have to do here. Ooh, see? Good thing I checked. No, I'm fine. Whew. Thank goodness. Life is good. All right. So is the answer 20 meters? Is the answer 125.67 meters? Is the answer 0 meters, or is the answer 40 meters? I've got a good amount of y'all. So clickers, that is another thing I need to update you all. Today is the last day where they will not count towards your final score. Today is the last day for you to basically have no risk in terms of whether or not it's working. Friday, they're going to start counting towards your final grade. So, make certain your clickers are registered. If you have a physical one, make certain you linked it on web courses. On web courses, the link to the side, this is iQuicker. That's how you register physical ones. If yours is digital, make certain you use that link I sent out in the announcement. Make certain you're linked to the class. How will you know? If after today's class, so Thursday or something when I post these grades for today's class, if you have 0 points and you responded to questions, something is wrong. And those are the 2 first solutions I'm going to tell you. Did you link the physical one on web courses? And if you have a digital one, did you link it through the link I sent out? If you did not do those, do that first and then contact me. All right, I'll wait 5 more seconds. We'll go to 50. 5, 4, 3, 2, 1. And let's see if we know the difference between distance and displacement. Also, if we remember our circle. So it's a circle with a radius of 20 meters. And if we remember our handy-dandy equation here, distance is just how far you traveled. This is distance, so it matters how far you traveled. Doesn't care where you started, doesn't matter where you ended, just cares how far you traveled. And if I go around a circle, I have traveled the circumference, that is 2 pi r. If you multiply those numbers, you should get 125.67. There we go. Fantastic. Circles are super important. We're going to see those later on. All right. Same exact question, same numbers, but what is the displacement? If I go once around the circle, what is the displacement? Is it 20 meters, 125.67 meters, 0 meters, or 40 meters? We're only going to go to 40 seconds on this one. I'll go 5 more. 5, 4, 3, 2, 1, 0. All right. Great job, everyone. Or at least the vast majority of you got right. If not, that's okay. That's why we do these. It's 0 meters. I started and ended at the same spot. When we're talking about displacement, it's all about where you start and stop. So very, very important to distinguish those two. All right. Let's solve some problems. So the position of a particle moving along the x-axis is given in meters by this equation. X of t equals 4 minus 2t. Why is that equation? Who knows? Who cares? Doesn't matter for this problem. At what time does the particle cross the origin? And what is the displacement of the particle between t equals 3 seconds and t equals 6 seconds? So, yes, you could draw a picture here. You could draw the graph. I'm not going to bother with it, but that is a thing that could help you answer this, actually. What I'm just going to do is write down our givens. So our given here is, honestly, the equation. As weird as that sounds, that's a given. That's a piece of information we have. At some point, we'll care about T1. That's our, you know what? Let's actually be T naught. That's our initial time. And subsequently, this will be T final equals 6 seconds. So let's make certain we're using those terminologies. All right, what are we solving for? A couple things. We are solving for at what time do I cross the origin? So at what time, basically, does x equal 0? Is kind of the way I'm going to write that. It's a little weird. In fact, maybe I even put it in words. Time when x equals 0. That's just when we pass the origin, that's when x equals 0. And then we're also solving for delta x. Displacement for one dimension can be just put as delta x. When we get to 2 dimensions, we'll use a different variable. But we're in 1 dimension now. We're living the dream. All right, step 3. I mean, honestly, the equation is kind of a given, but so this one's a little funky in that way. So 0 equals 4 minus 2t. So when x equals 0, what is t? We just replace x with 0, and we solve. We'll end up doing that. So step 3 and 4 kind of get fuddled together here. But I'll go ahead and do another one. The other equation we have is we're going to do x at t final minus, actually let's write this a little differently, my change in location is going to be where am I located at t final minus where am I located at the initial. So this is a function, depending on what time we plug in, it spits out a location. So we'll do one at a time. We're kind of solving part A and part B simultaneously here. The first one, again, is kind of already written for us, so saying we have an equation is a little funky, but does the job. So 0 equals 4 minus 2t. I'll let you all do the algebra yourselves. Again, I have high expectations for you. You've taken calculus. I expect you can do algebra. The answer is 2 seconds here. And then the second one is going to be, we're going to have to actually plug in the thing. So we're going to do 4 minus 2 times 3. Nope, that's not quite right. Make certain you don't mix up your finals and your initials. So I just plugged in 6 seconds into this equation. And so that's 4 minus 2 times 6. That will give me my final position. Minus, and I touched the cable, so it got very angry. Minus 4 minus 2 times 3. There we go. It just needs a little bit of time to calm down. Equals. And at this point, you can either plug the whole thing in your calculator. We can do a little bit of symmetry stuff here. 4 minus 4 is going to cancel out. Negative 12 minus negative 6. That's going to be 12 plus 6. Pro tip. This may seem stupid. I'm going to plug this in a calculator. Yes, I can do this in my head. But you would be amazed at the stupid mistakes humans make. I am a human. You are a human. You are going to make stupid math mistakes in your head that you're going to look at later and say, what? How did I forget that? If ever, lean on your calculator. It is useful to do math in your head, but when push comes to shove and you're trying to calculate something and there's a lot that's... So in your all's class, test grades are basically the biggest consequence. Are you going to get the question right or wrong? In the real world, this is real world, if you become an engineer one day, that could be whether or not a building falls. That could be whether or not a rocket succeeds. Do everything in your power to reduce human error, and one of those is sometimes plugging in stupid math into a calculator so that your brain doesn't do this. This will not mess up. This will mess up. Trust me, if you haven't already experienced that, you will. You will. So I'm actually going to plug this entire thing in here. 4 minus 2 times 6 minus 4 minus 2 times 3. Make certain I have all my parentheses in the right place. It seems stupid. It seems almost insulting even. But trust me, you're gonna make mistakes. And anything you can do to reduce those is not stupid. I would rather my intelligence be insulted and have the right answer than feel like I'm the smartest person in the world and make a stupid math mistake. Honestly, the latter is more embarrassing. Yeah.
So because it didn't give a... Oh wait, never mind. I see it.
Oh yeah, no problem. Yeah, the only stupid question is if you're asking something that's already written on the board. So like, as I say that, people say there's no stupid questions. There is stupid questions. Please, ask your questions though. Risk it being stupid. It's worth risking it being stupid. But yeah, like my students, in high school, one of the stupid questions is, what are we doing today? When I literally just explained what we're doing today and they just weren't paying attention. So that kind of stuff is always a good time, right? Who doesn't love saying the thing you just said? Yeah. Oh, that's a great question. So we have this negative 6 meters, and is it absolute value or not? That's a great question. So displacement is a vector, so this negative does mean something. This negative here means that wherever the origin was, we're to the left of it. A negative value means I'm located to the left of this. So this is actually a very great point. I'm really glad you asked that. So this negative 6 here means I'm in the negative x. Or if I kind of drew a graph of this, let's just draw a graph of it. I'm somewhere over here. So it means something, and that's awesome. I'm really glad you asked that. If I ask for the magnitude of the displacement The magnitude of something is the absolute value. So if I were asked for the magnitude of something, we take that vector and we turn it into a scalar, and scalars don't have positives and negatives. Kind of, sort of. In our case, they won't. That would just mean I'm located 6 meters away. Anyway, great question. All right, on to velocity. 1 variable down, 2 to go. There's only 3 variables, I guess 4. Time, position, velocity, and acceleration. I'm going to spoil all of them for you. So velocity is the next one. It's a word that you all have heard before, very likely. Velocity, very important. It is different than speed. Velocity is the rate of change of position. The variable is v. It's very nice. It matches. Not all variables match. The unit is meters per second. And now you all get to see why it's the calculus course. We'll get to do some calculus here. Velocity is the derivative of position with respect to time. So whenever we're saying rate of change means derivative. Rate of change, that's something that's kind of useful for you all to have in your head. Rate of change is a derivative because that lets us get infinitesimally small changes. If we're finding the average, then we can just use change in x over change in t. But if we want to be infinitesimally, kind of get that infinitesimal difference, that's what the derivative does for us. And I put the general one here, dr dt. R, remember, is the displacement vector in 3 dimensions. R is the displacement vector or the position vector in 3 dimensions. This week, we're just working in 1 dimension, so we can just replace that with x. Next week, we're going to have to be using r's because we're going to have x and y together. So, it's important to I'm doing both because it's just good to get in the habit of it. X for 1 dimension, if we're just in the x direction. Next week, we'll start using r's. Derivative of position is time. That's the key part here. And you can see a beautiful graph. At the slope of any point on that graph is the velocity. If I have a position versus time graph, the slope at any point is the velocity. That's what a derivative gives you all. Now, all right, so super straightforward. An object starts at x equals 2 meter and ends at x equals 10 meter. If it takes 4 seconds, I'm going to reword this last part. What is the average velocity? What is the average velocity? I'm going to specifically reword that because if I didn't say average, then it gets a little funky. What is the average velocity here? Is it 2.5 seconds, 0.5 seconds, 3 seconds, or 2 seconds? And the key to this is remembering that velocity is defined as the change in position over the change in time. How far did I travel? How long did I take? And that's where the units come from. Meters per second. Meters divided by second. When y'all drive your car and you're measuring your velocity, it's the miles per hour. Distance per time. All right, we'll go to 120. Any clicker question I ask you all, the math will always be very strict, very simple, if there's even math. 5, 4, 3, 2, 1. The purpose of these is not to see your all's math skills, but conceptually to get the understanding. The problem sets are where all the fun math will come in. All right, so velocity, average velocity, is my change in x over change in time. So xf minus x naught over t final, if I write this all fancy. T naught. So I'm writing out way more than I really need to here, but so 10 minus 2 divided by 4 minus 0. We assume it starts at 0 seconds. If it takes 4 seconds, that is your change in time. 8 over 4. And again, better safe than sorry. See, look at that. That's wrong. 2 seconds. Told you all, I almost put the answer as 2.5 because my brain almost did something really stupid. Because they do that. Did I do something stupid?
Well, shouldn't it be meters per second?
Ooh, yes. Yeah, all my units here were completely ridiculous. So I don't know what I did when I was doing there. So meters per second, meters per second, meters per second. Good catch, good catch. At least I was consistent in my mistake, but yes, that was a mistake. Meters per second, very important you put your units, for sure. If you're calculating velocity, and the beautiful thing about units, anytime you see meters per second, it's always velocity. It does not matter what type of problem you're solving. It does not matter, if it says meters per second, it's always velocity. That's true of every unit. Distance gets a little funky because distance means a whole bunch of things depending on a problem. But yeah, units, that's what they're used for. Great job, everyone. Great job, great job. All right. This is a short slide, but a very, very important one. Most of it's fairly obvious, but this is something you have to be able to do in problems. So step one is identify the givens. The givens will not always be given as numbers. Sometimes you'll have to tease out givens based on wording. In this case, if I ever say at rest, stationary, not moving, still, staying at the same location, literally anything that means that it's not moving, by definition, velocity is 0. Right now, you all aren't moving, your velocity is 0. So that is a piece of information that you have to be able to identify in these problems. I will not tell you in basically the vast majority of problems that the initial velocity is 0, but you will very often see this kind of wording. Still, at rest, stationary, not moving. Anything that means not moving means that v is 0. This could be at the beginning of a problem. This could be at the end of a problem. A car is moving at 30 meters per second and then comes to rest. The final velocity is 0. A car is at rest and accelerates to 30 meters per second. The initial velocity is 0. You have to be able to identify that, and you're going to get a lot of practice by just doing problems. It comes up so often. Okay, position versus time graphs. We need to be able to read graphs. Graphs represent, so a picture says 1,000 words, a graph shows 1,000 data points. Graphs are immensely useful for visualizing data, something that you will need to be able to do in whatever job you, very likely you'll need to do. So to that end, remember that v is defined as the derivative of x with respect to t. So dx dt, meaning it is the slope. So the position graph, to go from position to velocity, you find a slope at every location. So if we look at this first chunk, the slope of this line is it goes up by 4 and it goes over by 0.4. 4 divided by 0.4 is 10. So my velocity is 10 there. Now, we get this dotted line here because whenever you have a, I forget exactly what they call these, but a really sharp point, you can't get the slope of a really sharp point. It's it's not discontinuous. I forget the exact wording.
The cusp?
The cusp. Yeah, if there's ever a cusp, we cannot find the slope of a cusp because you can't. So we get these dotted lines. The slope of this one down here goes from 4 to -2, goes down by 6, goes over by 0.2, so that gets us 6 divided by -6 divided by 0.2 is -30, and you can kind of explore each of these points. There's a question like this on your problem sets. Do not look at the solution when trying to figure it out. Use the solution to check your answers. That's a pro tip for y'all in general. If you use the solutions and you have them, if you have a worked out solution and you're trying to solve a problem and you have that worked out solution next to you and you're just reviewing it, you're looking at it constantly to figure out the next step, you are not studying in a way that's going to make you successful, because what you're doing there is you're training in a way that doesn't match the assessment. When y'all take a test, I'm not going to give you the solution right next to it to figure out the next step every time. The solutions are very useful, and you 100% should use them if you get stuck. If you get stuck, then yes, refer to them so you can move on, but do not solve a problem by just copying the solution over. You're not preparing yourself in a way that actually matches the test, and you're just kind of shorting yourself, and then you're going to be so confused in the test, you'll be like, oh, I totally know how to do these, I solved some of these problems. Kinda. You solved them with someone kind of walking with you the entire way, and the reality is on a test, that's not going to be the case. So, just make certain that you all can solve, use solutions. Great resource, definitely. If you all have a problem you don't know how to do it, Google it. I have no problems with that, except during a test, but you're in person, so you can't Google it. Learn how to do it, but do not use the solution as a handhold throughout the entire thing. Use it when you're stumped. Only use it when you are stumped and don't know what to do next, or if you got the wrong answer and you don't know why. Then go back, find that, and then put that solution aside as quick as you can, so that way you're not just leaning on it the entire time. Okay? That's just a very important strategy for studying for any of your all's math science classes. All right, velocity versus speed, I touched on this. Velocity is a vector, has a direction and magnitude. So just like distance and displacement are different, velocity and speed are different. Speed, I'm going 30 miles per hour. Velocity, I'm going 30 miles per hour east. Both are useful in different contexts. Generally, velocity is more useful. You're never going to get to Tampa if you're traveling 30 miles per hour east. So, velocity matters, or the direction matters. But every now and then, if I ask you for the magnitude of the velocity, that's effectively the speed. Or if I ask you for speed, that's the magnitude of velocity. There's no positives, there's no negatives, it's just, here's a number. Doesn't have a direction to it. So there you go. If I ask for velocity, I care about direction. If I ask for speed, I just want the number. And honestly, I don't want negatives with it. Because when we come to speed, no one tells you, the cop pulled you over and they said how fast you're going. No one says I'm going negative 60 miles per hour. That doesn't mean because they're asking for speed. They're not asking, if you want to be precise, you could say 60 miles per hour east then, or 60 miles per hour west. All right. So here we go. Particle moves along the x-axis in meters according to x of t equals 10t minus 2t squared. What is the instantaneous velocity at 2 seconds and 4 seconds? What is the instantaneous speed at these times? And what is the average velocity between 2 seconds and 4 seconds? So our given, again, kind of funky, but this is just how this problem works. Our given is the equation. That is a given piece of information. We are given that our initial velocity that we care about, t naught, is 2 seconds. We are given that our final velocity is 4 seconds. And that's all we kind of got at this point. What are we solving for? We are solving for the velocity at 2 seconds. We are solving for the velocity at 4 seconds with the little vector signs over it. We are solving for the magnitude of velocity at 2 seconds. So I guess I can chuck that in the parentheses as well. And we are solving for the magnitude of velocity at 4 seconds. And last but not least, we are solving for v between 4 and 2 seconds. How do I want to write this notation? Average velocity. We're just going to put v average. I won't be able to clarify in any simple way that that's between 2 and 4 seconds there. So v average. 5 things to find. Seems like a lot. It really isn't too bad. How do I solve this? First, the equation I'm going to use is that v is dx dt. That is the bread and butter here. We also need to remember that v average is your change in x over your change in time. Same one we used before. So ironically, the average velocity one is going to be, I'll show you 2 ways to do it. I was like, that one's ironically probably going to be the most steps. All right, so we get to do some derivatives. Spend a few seconds, see if you all can figure out this is as easy as a derivative gets. I'm not going to give you all any crazy problems to take derivatives. I'm not going to give you all any crazy problems to do integrals. You'll get plenty of practice with that in your Calc 2 and Calc 3. At no point with Calc 2 is when you learn all the fancy integrals. I'm not going to be having y'all do fancy integrals. We will use simple calculus in this class just to get the idea across of how it works in physics, but I'm not testing your ability to do crazy integrals in this class, so hopefully that's some peace of mind. All right, so the derivative of this is going to be 10 minus 4t. Again, I'll leave that for you all if you're not certain why that was. Try it out later. So now we just plug in the values. v of 2 is going to be 10 minus 4 times 2, which is going to come out to 2ms, and it's a positive value. So that way gives us our vector. So it's in the positive x direction. We can put a little x hat here if we really want to be fancy. I'm not too worried about that as far as you all doing that or not in tests and stuff like that. And then the other one is 4 minus 4, and that one's going to be negative 6 ms x hat, 10 minus 16. The magnitude, yeah.
Is that x with a hat, is it like the same thing as the I and j?
Yes, that's a great question. Yeah, this x in the hat is the same as I and j. Great question. I could have put I hat there if I'd wanted to. Yep. X hat's just in the x direction. I hat is also in the x direction. Yeah, great question. Love that. All right, the magnitudes, super easy. The magnitude of v of 2 is just the absolute value of it. Absolute value of 2 is 2. Absolute value of negative 6 is 6. Super simple, but important for us to know that when I'm asking for magnitude, or I should say when I'm asking for speed, I'm asking for the magnitude. It's an important distinction to know. And I kind of ran out of room for C, so I'll have to probably go to another slide for that. That's no problem. I have everything I need here. So the cool thing is when you write out your givens, your goal with writing out your givens and writing out what you're missing is that you don't actually have to read the problem again. Because reading is great and wonderful, but looking at a list like this is just a way of organizing the information to make it easier to process. Very useful skill. Regardless of how much you do or don't write, I can almost always recommend that you all write the givens and the missing. Why keep referring to the problem every single time you need it? Jot down what's given, jot down what variable it goes to. Super, super handy practice. Anyone that does math, that's what you do. That's just like, you talk to anyone, that is the process. Because it's useful. We wouldn't do it if it was a waste of our time. All right, V average. We're going to do it 2 different ways. We're going to do it 2 different ways. One of the ways is the way I showed you all. V average is change in x over change in time, meaning xf. So I'll write it all. X at 2. Nope, got that backwards. X of 4. You know what? Let's just write it out a bit. xf minus x naught over tf minus t naught, which means I need to calculate xf, which means I have to plug in x of 4. So this is honestly the long way. It's going to work out for us. It's all fine. So we're going to have to calculate x of 4. So that's going to be, again, I'll leave this as an exercise for you all. But I'm 10 times 4 minus 2 times 4 squared. So feel free to come check this out, see why this is later, but I literally just plugged in 4 up there. I plugged 4 into my position equation. 10 times 4 minus 2 times 4 squared. And then I'll do the same thing for 2 seconds. Again, I'm moving a bit quicker because I want to try to get through as much kinematics as possible. Divided by 2. And that comes out to negative 2 ms. Double check my work because I've done silly things before. All right, something. Yeah, it should be. And that's why I'm like, I made a silly mistake here because we're going to find out when I do it later. Let's see what I did wrong here. Alas, when these things happen, sometimes you just have to write more than less. All right, so x of 4 is going to be 10 times 4. I was hoping not to have to do this, but I clearly made a mistake. I was able to catch the mistake because I'm going to show you the easy way to get the answer after this. 3 times 4 squared, that's looking right. x of 2 equals 10 times 2 minus 2 times 2 squared. That should be 12. All right, is that tracking what you all got? You are my checkers here. Great. All right, so 8 minus 12. My final time is 4. My initial time is 2. That's tracking. Ah, put those in the wrong spot. Oh, I put them in the wrong spot. So that's good to know. -4, so that's -4 over 2. All right, where did I bundle? Did I bundle? I didn't bundle. All right, someone said 4 though, and I'm feeling like 4 is right, and I need to double check why. All right. So that's one way of doing it. Now what I'm a little peeved about is the other way's not working, so I may have to revisit it next class. What we should be able to do, so what I'm doing in my head right now, which is making me question myself, is another way to get average velocity is you take your final. Ah, there we go. It's because I was doing it wrong in my head because I didn't write it out. All right. If I have two numbers, how do I get the average of them? You add them together and you divide by how many there are. This is an average. It also follows those rules. So this is a useful, we'll kind of mention it now. The average velocity is also, and we're going to actually see this later on, so it's a good foreshadowing. Take your final, add your initial, and divide it by 2. This is nothing fancy. This is literally how you get the average of any two numbers. You add them and divide by how many there are. Yeah?
Are you doing this with the magnitude or with the...
So in this case, because it's asking for average velocity, we have to use the velocities, which are the vectors. That's a great question. If I was asking for the average speed, then I would use the magnitudes. So -6 plus 2 divided by 2, and that also gets us the exact same answer. So there's two ways to get this. One of them was very quick. The other one required us to do more work. Sometimes physics works that way, where there's more than one way to get it. At the end of the day, sure, being efficient is awesome, but at the end of the day, getting the right answer is probably more important anyway. So do whatever you're more comfortable with when you're solving problems. Yeah? Yes. Yes, so I didn't put those right here. Yeah. And the reason I'm adding them is because the average is defined as add the numbers and then divide. So that's what I was getting mixed up in my head. In my head, I was subtracting them, and I was getting -8, and it wasn't kosher. All right, next class, I'd hope to get here. We'll do acceleration. It's just the derivative of velocity. It's derivatives all the way down. And then we'll talk about that, and yeah, do some problems on that graphs, and then we'll get to this goodies. The kinematic equations. This is going to be our bread and butter, y'all. Hopefully, we will definitely get to this and practice this next class. It'll be the main priority. All right, looking at it for y'all.